All right, so the next topic is synthetic and long division. So the next unit will be rationals, but this is technically polynomial division. So we wanted to introduce it now so that when you see it in the next unit, it's not the first time that you're trying to get reacquainted with it. Because you did do this last year, but I get it. It was before summer and you guys have learned a lot since then. So this is a great way to kind of get back into that. And if you're feeling uncomfortable with it or you don't feel like you're strong with it, then definitely hit some of those practices so that you can get through these with ease. So, but the end game for this is that we are looking at the end behavior, all right, of these two polynomials that are being divided by one another. So we have a quartic function divided by a quadratic function. And if you think back, if we have x to the fourth divided by x squared, we're going to end up with something that is degree 2 for its quotient, all right? And this quotient is going to be the end behavior for this polynomial division, okay? And you're going to be expected to find the quotient for this because we want to be able to find the end behavior asymptote for these functions. And it is a little weird because when we talk about asymptotes, you've discussed horizontal asymptotes, you've discussed vertical asymptotes, you've discussed slant asymptotes. But oblique asymptotes, they can be slant or like this linear function, but they can also be quadratic, right? So that is also considered oblique or a quadratic asymptote, all right? So you can divide high degree polynomials with a lower degree, and you'll end up, whatever your quotient is, you'll end up with the functions, the ends of that function tending towards whatever that quotient is, which we're going to dive more into that in the next unit. But for now, just focus on getting to the quotient so you can see what that end behavior asymptote is. So we will be using synthetic division, but because that's a degree 2, we will not. So we're going to set up our divisor, and then don't forget your 0 placeholders. And then we have our dividend, which is going to be 3x to the fourth minus 11x cubed plus 0x squared plus x minus 2. All right, the first thing we want to do is divide the leading terms for each of these polynomials. So we'll have 3x to the fourth divided by x squared, which is equal to 3x squared. And then we're going to go ahead and place that above the x squared. From here, we're going to multiply this term with every single term in the divisor. So 3x squared times x squared will end up with 3x to the fourth, as you should, because they have to cancel out. And then we'll have plus 0x squared, cubed, and then plus 15x squared. And we will be subtracting these. So your Algebra 2 teachers, maybe they told you a different method, and if it works and you're comfortable, then you can use that. You don't have to do it the exact same way. Like when some people multiply, they multiply by -1, so they're already subtracting it, and they don't have to add these parentheses and minus signs. So whatever works for you. And if you're uncomfortable with the way you do it, maybe try this method and see if it works. Okay, so we have negative 11x cubed minus 0x cubed, and then 0x squared minus 15x squared. And then we're going to bring down the x and the 2. And we'll continue this process. So now we have negative 11 x cubed divided by x squared. So negative 11x cubed divided by x squared, we end up with negative 11x. So that'll be up in the quotient, minus 11x. From here, we repeat, multiply this with all three terms in the divisor. So negative 11x times x squared, we're going to get negative 11x cubed. And then negative 11x times 0, we get plus 0x squared. Negative 11x times 5, we get negative 55x. and then we'll subtract those. Okay, these will cancel out. And then negative 15x squared minus 0x squared. And then x minus negative 55x, we get 56x. And then we'll bring down the 2. All right, so we're going to divide negative 15x squared by x squared. And we're going to end up with negative 15. So to do this, you need to know your properties of exponents. All right, 4 minus 2 is 2, 3 minus 2 is 1, and then 2 minus 2 is 0, so the x goes away. Okay, so we'll put negative 15 as part of our quotient, last one, and then we'll multiply that 15 with all 3 terms in the divisor. So we'll end up with negative 15x squared, and then negative 15 times 0, we get plus 0x. Negative 15 times 5, we get minus 75. And we're subtracting that. And these cancel out. We get 56x, and then negative 2 minus negative 75, we're going to end up with 73. Plus 73. Now we have a constant up here, so we're done. All right, our quotient is done, and then we end up with the remainder down here. So this is our remainder. And then up top here is our quotient. Okay, so part B says to rewrite the function f of x equals 3x to the 4th minus 11x cubed plus x minus 2 divided by x squared plus 5 in the form of quotient plus remainder over divisor. So I really want to emphasize this. Like, we have this function f of x is equal to 3x to the 4th minus 11x cubed plus x minus 2 all over x squared plus 5. We didn't change that just by doing long division. We're simply rewriting the function, all right? So our quotient was 3x squared minus 11x minus 15, okay? And then we have plus our remainder, which was 56x plus 73 divided by x squared plus 5. So we didn't change the function. These two are equivalent, all right? This just says that we were able to divide it and get this quotient, and then what we could not divide is our remainder. Therefore, we still have this over here, all right? So we were able to successfully divide the beginning 3 terms. It was just over here we're left with this because we can't divide x by x squared, right? There's not enough things in the top. All right, so what we want to pull from here is that our quotient, which is 3x squared minus 11x minus 15, that is going to be your end behavior asymptote. This is what your graph or the original function is going to tend to, all right? So we have this quadratic in here, which means the ends of the graph will be tending towards that. We don't have any vertical asymptotes because there's nothing you can put in the denominator that will make it 0. So this asymptote is the only asymptote affecting the ends of the graph. And then what is the end behavior asymptote? Well, 3x squared minus 11x minus 15 is the end behavior asymptote of f of x. And again, we're going to dive more into this in rationals. Like, you'll be graphing these, you'll be seeing them in the calculator and things like that. But for now, just get comfortable with your quotient being your end behavior asymptote for these for this polynomial division. Now, the process won't always take that long. This one says use synthetic division or linear division to divide. So now we're dividing with a divisor that is to degree 1. So for synthetic division, just remember multiply, add. Multiply, add, or multiply, add, multiply, add, multiply, add. So we're going to use the solution for this factor, which is 3. And then we're going to use the coefficients from each of the terms. You still need to think of your 0 placeholders, but we don't have any in this one. So we'll have 2, -7, 20, -12. So we'll bring down the 2, multiply 2 times 3, so we get 6, and we are adding here. -7 plus 6, we get -1. -3 times -1, we get -3, so we're left with 17. 3 times 17, we get 51. -12 plus 51, we'll get 39. So we have our quotient here, and then our remainder is over here. Okay, this is technically our divisor. This is our dividend. Okay. So part B says to rewrite the function in the form of the quotient plus remainder over divisor. So again, this is equivalent to what we are about to write. Okay, if you plug them in your graphing calculator, they will create the same curve because we didn't change it. It's an expression, not an equation. We didn't change anything. We're just rewriting it so we can see the quotient, which is our end behavior asymptote. So f of x, I'm going to use this, and because this was degree 3, we're now going to start with degree 2 in our quotient. So we have 2x squared minus x plus 17. And then our remainder is 39 over our divisor, which is x minus 3. And then what is the end behavior asymptote? It's going to be our quotient. So 2x squared minus x plus 17 is the EBA for f of x. So again, we have another quadratic asymptote. But this one also has a vertical asymptote. So this will be affected by 2 asymptotes, but the end behavior will only be affected by the quadratic because the vertical asymptote is just 1, it's at 1 x value. And then the function just goes on and does what it wants after that, or based on the function itself. Okay. All right, hope this helps. The next, I will be doing some optimization.